Hello, my name is Christy, and we'll be going over the Spring 2022 final, question number 5, cascading numbers. So for this question, we want to complete the function cascade, which takes in integer base, a function fn, and a non-negative integer count. And cascade returns a sequence of numbers starting with base, fn of base, fn of fn of base, and so on, count number of times, and then continues the sequence in reverse back to base. So the first thing I want to do is look at the doc test they provided just to get a sense of what this function is supposed to do. So when base is 5 and the function is lambda x 2 times x and count is equal to 0. So when count is equal to 0, this means we want to do this 0 times, so we end up returning an empty list. Next, now the only thing that's changed is the count. So count is now equal to 1. But if we look right here, we have to start with base. So since 5 is the base, that's why we return a list with just 5 in it. Now count is equal to 2. So we first start off with 5 as our base, and then we have to do this 2 times. So this is the first time right here, and this is the second time right here. So applying the function to 5, 5 times 2 is 10, that corresponds to here. And then we want to reverse back to base. So the last item is 5. Next, count is equal to 3. So we started with our base. So base is 100. And let's apply the function. So it's x minus 4. So 100 minus 4 is 96. And we want to do this 3 times. So this is the first time, second time, third time. And then we need to go reverse back to the base. So as a result, that's why we go up to 96 and then 100. And then same thing for this last example case. So we do this 5 times. So 1, 2, 3, 4, 5. And then we return back to our base of 100. So right off the bat, the steps for recursion is to first find our base case. And then we have to trust our recursive leap of faith. So these two correspond to the base case. So this is base case corresponds to what happens when like the recursion process is over, like what makes the recursion call stop. So this happens when there are 2 cases for this. So if count is equal to 0, we just want to return an empty list, right? So as such, as seen as like the doc test, we just return an empty list. And when count is equal to 1, this corresponds to just the first sequence, like the first item in our sequence corresponding to base. So we just return this and this list with base inside. And finally, this is a little bit of a tricky part. Now we need to decide what our recursive leap of faith is, right? So we can see that the variable names are actually very helpful in this. So this is called middle. And as we can see in our doc test, they always start with the base, right? So the base is here, and it's also here, and all this stuff here kind of corresponds to the middle part. So that makes me think, okay, we must return base here. And we need to add the middle part, and then base again. So now this is our recursive leap of faith part. We're going to call cascade again. And if we look up here, it's like function base. So we end up calling function to our base. And then the function stays the same, right? And then count. This is the weird part. So we want to do it however many count number of times. So once we do, if for example, if count is equal to 5, then we have to do it 5, and 4, and 3, 2, 1. So as we call cascade, like each time, we want to decrement by 1. So count minus 1. Okay. Oops, I filled it into skeleton code. Let me just put it down right here. So return empty list. We return a list with just base. And we call function on the base. And then same function, count minus 1. And then we return base plus middle part plus base. And the middle part, we just have to trust the recursive leap of faith. So moving on to part B, with respect to the term count, what is the runtime of the function cascade? So the important part of this question is that it says with respect to the term count. So what is count here? So count represents the number of times we have to like call a cascade function. So for example, when count is equal to 5, so you do this 1, 2, 3, 4, 5 times, and then we have to also go in reverse all the way back up to like our base number. We can kind of use the process of elimination here, so it won't be constant because we're doing this in respect to count number of times. So even though count, for example, if count is equal to 5, constant would mean it would do this call 5 times, but that's not true. It won't be exponential either or polynomial because those are like we're doing it in respect to count, and count always decrements by 1. So as a result, it's linear. Hopefully that helped. Good luck with studying.